A ship packed with containers has just crossed the Caribbean, paid a fee exceeding hundreds of thousands of dollars, and in return, gained 2 weeks over any route that goes around South America. A few hours later, a similar cargo ship crosses the Sinai Desert and shortens the journey between Asia and Europe by more than 4 miles. These shortcuts excavated by engineering transformed global commerce, and you feel the impact when you check the price of your next cell phone or when you track a package in the delivery app. In the next few minutes, we will explain how the Panama Canal and the Suez Canal were born, how they work inside, why climate and geopolitics dispute every inch of these waterways, and which high-tech solutions are already being tested to avoid queues, groundings, and bottlenecks that cost billions. To understand the power of these corridors, it is useful to imagine the world before them. In the 19th century, a journey from New York to San Francisco required going around Cape Horn, a region of colossal waves, unpredictable winds, and legendary shipwrecks. The crossing could take up to 6 months in open sea. With the Panama Canal officially inaugurated in 1914, the journey was reduced to 25 days on average and exchanged rough seas for a relatively calm route between artificial lakes surrounded by jungle. The Suez Canal, opened in 1869, eliminated the complete journey around Africa and gave European empires direct access to spice and silk routes in Asia. As a result, freight costs plummeted, travel time dwindled, and entire logistics chains could exist without enormous inventories. This efficiency gain still defines today how perishable products, electronic components, and even automobiles reach consumers. Let's focus on the Panama Canal, an engineering masterpiece that still amazes experts and laypeople alike. When American engineers took over the project at the beginning of the 20th century, they faced a challenge that many considered impossible. They needed to cut through a mountain range, control a river with irregular flow, create what was, at the time, the largest artificial lake in the world, and build the largest movable gates ever conceived. What makes the Panama Canal so special from an engineering perspective is how it combines solutions to overcome geography. The Isthmus of Panama is mountainous, with torrential rains and a river, the Chagres, that alternates between periods of intense flow during tropical storms and low levels in the dry season. The solution was brilliant in its apparent simplicity, but revolutionary in its execution. The engineers created a colossal artificial lake, Lake Gatun, by damming the Chagres River with a huge earth dam. This dam was 8 feet long and 98 feet high, being at the time one of the largest dams in the world. The formed lake was so large that when ships are crossing its central part, it is not possible to see any of the shores. The true engineering prodigy, however, are the locks. These gigantic concrete structures function as hydraulic elevators, raising and lowering ships by 85 feet. The original locks use a purely gravitational system, without pumps or motors to move the water. Each chamber fills and empties simply by opening and closing valves at the bottom, allowing water to flow naturally. The lock gates are marvels of mechanical engineering. Each gate is up to 82 feet tall and weighs more than 700 tons, but is so perfectly balanced that it could originally be operated by an electric motor of only 40 horsepower. They are designed in a V shape, with the vertex pointing against the water flow, using the water pressure itself to help seal them. It is a brilliant example of design that uses the forces of nature to its advantage. The most challenging part of the construction was the Culebra Cut, where the canal crosses the Continental Divide. This 8-mile cut through solid rock required the removal of more than 131 million cubic yards of material. To give an idea of the scale, this would be enough to build 25 pyramids the size of the Great Pyramid of Giza. The excavation technology revolutionized construction. The Americans deployed more than 100 Bucyrus steam shovels, gigantic machines for the time, which could remove tons of material in a single bite. A railway network with more than 99 miles of tracks was built just to transport the excavated material away from the canal. At its peak, 160 trains loaded with debris left the Culebra Cut daily. The challenges did not stop at excavation. Landslides were constant, with entire hillsides collapsing back into the newly excavated canal. The solution was to create gentler slope angles on the sides of the cut, although this meant removing even more material. Even today, teams of geologists constantly monitor the canal slopes to prevent landslides. The canal expansion, completed in 2016, brought even more engineering innovations. The new Neo-Panamax locks are a technological leap compared to the originals. Instead of gates that rotate like the originals, the new locks have sliding gates that retract into niches in the walls. Each gate weighs up to 4,000 tons and is 187 feet long by 33 feet thick. They are so heavy that they move on reinforced steel wheels with rails embedded in concrete. One of the most innovative aspects of the new locks is their water reuse system. 3 side basins accompany each lock chamber, functioning as temporary storage for water during the process. When a chamber needs to be emptied, instead of all the water flowing to the ocean, 60% of it is diverted to these basins. When the next vessel needs to rise, this water is reused, significantly reducing waste. The valves that control the water flow in the new locks are masterpieces of hydraulic engineering. There are 158 giant valves, each weighing up to 30 tons. They allow a precisely controlled flow of water between chambers and side basins, ensuring ships rise and fall smoothly, without excessive turbulence. The concrete used in the new locks is also special. A specific mixture was developed to resist salt water and have a lifespan of 100 years. During construction, teams worked day and night for 4 years, pouring more than 6.5 million cubic yards of concrete, enough to build 20 stadiums the size of Maracanã. The canal's control technology is equally impressive. The Maritime Traffic Control Center in Balboa looks like something out of a science fiction movie. In a spacious room with giant screens, controllers monitor each ship in the canal and in the approach areas. Using an automatic identification system, they can see the exact position, speed, and route of each vessel in real time. Canal pilots use advanced technology to navigate with precision. Differential GPS devices allow positioning ships with centimeter accuracy, essential when large ships navigate through the narrow caliber cut with little margin for error. On foggy days, radars and infrared sensors allow navigation to continue safely. The canal mules, special locomotives that accompany ships in the locks, are examples of specialized engineering. Each locomotive has a cable system that attaches to the ship, keeping it centered in the chamber. They don't pull the ship, but stabilize it during the raising or lowering process. The original mules, in operation since 1914, have been gradually replaced by more modern models, but the basic principle remains the same. The current water crisis of the canal is driving new technological solutions. Engineers are testing advanced hydrological modeling systems that use artificial intelligence to accurately predict water levels in lakes and optimize the use of available water. Sensors throughout the canal constantly monitor water levels, river flow, and other parameters, feeding a central system that helps with operational decisions. A revolutionary project under development is a saltwater gate system at both ends of the canal. These gates would create a barrier between the fresh water of the canal and the salt water of the oceans, allowing ships to enter an initial chamber filled with seawater. After being sealed, the salt water would be pumped back into the ocean and replaced with fresh water, significantly saving the precious resource. Another promising technology is the modernization of the original locks, with systems similar to those of the new locks, including water reuse basins. Studies showed this could reduce water consumption by up to 50% in the original locks, without decreasing their capacity. To combat drought, advanced watershed management methods are being developed. Drones equipped with multispectral sensors map the forest around the canal, identifying degraded areas that need reforestation. Real-time rainfall monitoring systems, with hundreds of automated stations spread throughout the basin, provide data for hydrological models that help predict river behavior. Technology is also transforming how the canal schedules ship passages. Advanced algorithms calculate the optimal sequence of vessels, considering their size, weight, speed, and water consumption, maximizing the number of ships that can pass with the available water. This system was crucial during the recent water crisis, allowing the canal to maintain a reasonable level of operation despite severe restrictions. The future of the canal may include even more advanced technologies. Research projects are exploring the use of autonomous tugs that could position ships in the locks with millimeter precision. Other studies assess the use of specially designed barge trains to transport containers across the isthmus, consuming much less water than conventional ships. A particularly interesting area of innovation is the integration of renewable energy sources. Floating solar panels are already being tested on Lake Gatun, generating clean electricity while reducing water evaporation. Advanced hydroelectric turbines capture energy from water flowing out of the locks, transforming what would be waste into electricity for canal operations. The Panama Canal is also at the forefront of green navigation. An economic incentive system rewards ships that demonstrate environmental efficiency, with reduced rates for vessels that emit less carbon. This policy has encouraged shipping companies to invest in more efficient and less polluting ships, transforming the canal into a catalyst for the modernization of the global merchant fleet. One of the most ambitious projects is the Smart Water System, which integrates various technological elements. Flow sensors, weather stations, satellites, and modeling systems work together to create a holistic view of the canal's water cycle. This system allows for more precise decisions about when to release water from dams, when to restrict traffic, and how to maximize every available drop. An often forgotten aspect of canal engineering is its traffic control system, which works like an airport for ships. Each vessel receives a specific slot with precise times to enter the canal. Advanced tracking systems allow the Canal Authority to monitor the progress of ships hundreds of miles away, adjusting scheduling in real time to maximize efficiency. Engineering challenges continue to evolve. With increasingly larger ships being built, there are studies for a potential third expansion of the canal. Engineers are considering even larger locks or completely new solutions, such as ship elevators, which could move vessels using less water than traditional locks. The Panama Canal represents much more than a simple waterway. It is a testimony to human ingenuity, a work that continues to evolve with new technologies and challenges. From the precise mechanical engineering of its locks to the complex algorithms that optimize its traffic, the canal demonstrates how creative technical solutions can overcome seemingly insurmountable obstacles. The next time you receive an international package or fuel your car, remember this incredible technological corridor cutting through the Central American jungle, where century-old engineering innovations work side by side with the most advanced technologies of the 21st century, ensuring that global trade continues to flow efficiently and sustainably. If you like this video about the technological wonders of the Panama Canal, don't forget to leave your like, subscribe to the channel, and activate the bell to receive notifications. In the comments, tell us what other engineering masterpiece you would like us to address in our next video.